Hey guys, welcome to today's lesson looking at exercise 4K, questions 8 to 12, some requests from my Year 11 for IB studies. Okay, first of all, let's have a look at this question. It says here that we have a rectangular pig pen. It's built against an existing brick fence or a wall, let's say, for example, and we have 24 meters of fencing that's used to enclose an area of 70 square meters. That means the only part of my perimeter or my fence are those three sides, and they plus together to give 24. Let's call these side lengths x. So if they're x, and I know that I'm going to add x plus something to make 24, then an expression for this length will be 24 subtract 2 lots of x. Remember, we don't need this other side here, so it's just 24 take away 2x. Now the reason we do that is because we want to link that to the area, because that's the value that we've been given. Now we know that the area is side times side, right? I've got to put that in brackets. We know that the area is 70. If I expand it out, I get 24x take away 2x squared. I want to let it equal 0 because that's how we know we can solve our quadratics. We get negative 2x squared plus 24x minus 70. Okay, now if you're doing this without using the graphics calculator, I'd probably tell you to go to the left hand side and make it to be 2x squared minus 24x plus 70 equals 0. Just means it's easier to solve by factorizing, but for us it doesn't really matter. I'm going to go to equations mode. Let's go in to make sure that we're in the polynomial and the degree of 2. So we can type in negative 2. We've got that there. We've got positive 24 and we've got negative 70. Again, it doesn't really matter which version you use, the one, the green one, the black, they'll still come out to be the same answer. If I press solve, we get x equals 7 and x equals 5. Now, of course, if one of those two values were a negative, okay, then they will be discounted because we know that x must be greater than 0. But in this case, they both work. So you must give both possible answers. Now for my answers here, we know the dimensions is x by 24 minus 2x. So the area 1 could equal 7 times, well, 2 7s are 14, so 24 take away 14 is 10. That's my first possible answer. Or area is equal to 5 by 2 5s are 10, 24 take away 10 is 14, and they're my two possible areas. Okay, sorted. Next question. Again, at any stage, guys, if you want to pause this and have a crack at the questions, by all means go for it. Is it possible to bend a 20 centimeter length of wire into a shape of a rectangle which has an area of 30 centimeters? So first step is I want to draw that rectangle out to make it look at least visual for me. Okay, now so we've got an area of 30 centimeters. Now you've got a couple of options here, guys. We know, or we could let the side length be x. Now these two sides would both together equal 30 take away 2 lots of x. Sorry, no, that would let 20, because remember the perimeter is 20, all right? Could be 20 take away 2 lots of x. Now remember, that's for the both of the sides. So if I just want one side, what we can do is just halve that. Okay, so half of 20 is 10, half of 2x is 1x. So we've got there the length of 10 take away x. Again, that comes because the perimeter is 20 centimeters. Once we've got that, we can now start using this area. All right, now we know the area is equal to side times side. All right, so area equals 30, 10x minus x squared. Of course, we want to make it equal 0. So we've got x squared, so minus x squared plus 10x, and then minus 30. Of course, you can make it to the left-hand side. I'm going to come back to my trustworthy graphics calculator, or GDP. And then I can put in negative 1 for the first bit, positive 10, and then negative 30. And I'm going to let it solve and do its magic. We get no real roots. Okay, well, usually I might double check that to make sure that everything's right. In this case it is. Okay, so I'm going to write down no real roots. Or you could say solutions if you want. Therefore, no, it's not possible. Okay, alrighty. Next question. Question 10. We have a rectangular box has a square base and a height is 1 centimeter longer than its length. Okay, we've got x and x, therefore this is going to be x plus 1. Now part A says, suppose each side of its base has length x. Well, we've already done that. Show that the total surface area of the box is given by that amount. Remember, we can't touch that. We need to prove it. We need to get to it. It's simply there in case we can't get it, and we can do B. So if I look at the area of the base, that's x times x, right? Because they're the same length, and we have 2 of those areas. So we can say we've got 2 lots of x squared plus. Now if I look at this length here, that's x by x plus 1. And I've got 1, 2, 3, and 4 of those. So plus 4 lots of x times x plus 1. So area is equal to 2x squared plus 4x squared plus 4x. Area is equal to 6x squared plus 4x. I go back to the question, chuck a centimeter squared on, and I've got it right. Awesome. Part B will be the solving part most likely. It says if the total surface area is 240, okay, so I'm going to write that down. Remember, that gives me a mark. Find the dimensions of the box. I'm going to take the 240 across, let it equal 0, as you can see, and then I'm going to solve it. Okay, so I'm going to go back to my calculator here. Make sure I'm in second degree. So we've got positive 6, we've got positive 4, we've got negative 240. I'm going to press solve, and we get x equals 6, or negative 6 2/3, or 0.6 repeating. Now, we do know, I'm going to go back up here, that x must be greater than 0. You can't have a negative answer for a length, therefore x is equal to 6. You must state that. If you don't, you'll get marked down. Have I answered the question? No, I haven't, because I need the dimensions. So now I can put the 6 back in and have 6 centimeters by 6 centimeters, and x plus 1 is 6 plus 1 is 7 centimeters, and we've got our answer. Alrighty, okay, 2 more to go. Question 11. An open box can hold 80 centimeters cubed, which means we're talking about, that's right, volume. Okay, it is made from a square piece of tin plate with 3 centimeters squared cut out of each of the 4 corners. Find the dimensions of the original piece. So let's say the original dimension there is x meters. All right, we don't know what it's going to be, and that's x meters there. Now, of course, what we're kind of looking at is the volume. So I'm just going to draw this up a little bit, just so you can kind of have a better picture of what we've got going on here, because it's the volume. Now, remember that whole way across, before the 3 centimeters were taken out, were x. So if I took 3 centimeters from here, and I took 3 centimeters from here, that means I've got x take away 6 centimeters. Now this is a square on the bottom part, so that's also x take away 6, and we know that the depth, when I fold these up, are going to be 3. So to find the volume, what we're going to do is we're going to multiply these all together. Alright, or a perfect square. You could also put 3 brackets x minus 6 all squared. Okay, volume equals 3 times. Now, if I use a perfect square method, I'm just going to be having x squared minus 12x plus 36. Okay, you might want to go x squared minus 6x plus 36. It's up to you. Volume equals 3x squared minus 36x plus, I think it's 108 by looks of things. Now the volume we're told was 80. Okay, so I'm going to plug that in. Again, really important to actually put that step. Don't just assume that we know what we're talking about. Take the 80 across. 0 equals 3x squared minus 36x, and that's what's going to be plus 24. Come to my calculator. Okay, so we're going to get exit. So we've got 3. We've got negative 36. We've got positive 24. We're going to press solve. Again, I haven't got a very nice number here, but I'll double check my working out and I know it's correct. So we can say that x is equal to 11.3 or 0.7. Now, with that, this is positive, but see how if I sub that into that length, we get a negative number. Therefore, my actual answer, and I might even say x minus 6 must be greater than 0, therefore x must be 11.3. Okay, you can also work it out from up here, because if this is 0.6, we also know that's 3 and that's 3. That can't actually work out. Now this wants the dimensions of the original tin plate. So the original template is the x and the x. So in this case, therefore 11.3 centimeters by 11.3 centimeters. Alrighty guys, one question to go. Question 12, rectangular swimming pool. Before I even start this question, guys, let's draw that little rectangular swimming pool out. Okay, so I've got a rectangle there. We've got, so it's 12 meters long, 12 meters, and 6 meters wide. Okay, we got that. It's surrounded by a pavement of uniform width. All right, so let's draw the pavement of uniform width. Now, uniform width means it's exactly the same length all the way around. Okay, now we don't know what that width's going to be, but most likely we assume that that width there is going to be x meters, and that width there, x meters. Okay, what else have we got? We know that the width, the area of the pavement, so remember the pavement's all in green, is 7/8 of the area of the pool. Okay, well, that's quite important, because we know that the area of the pool is 72 centimeters squared. So if I want to find the area of the pavement, I don't probably need to know this at the moment, but if I need to find it, it's 72 times 7/8, okay, which I believe is going to equal to 63 meters squared. But we might have jumped ahead there. Let's have a look at the actual question. Okay, part A. If the pavement is x meters wide, show the area of the pavement is 4x squared plus 36x. So I need to find the area of the green bit in terms of an expression. So if I find the total area, that means the length of the big rectangle. Remember, that's x on either side. So let's say it's going to be 12 plus 2x. And then the height of it is 6 plus 2x. And I take away the 72, we're left with the green area. So we're going to say area equals 12 plus 2x, or 2x plus 12, times 6 plus 2x, or 2x plus 6. And then I'm going to take away the 72. We're going to do 12 6 72, plus 24x, plus 12x, plus 4x squared, minus 72. Then equals, we've got the 4x squared there. We've got the 36x, and the 72's cancel. Look at that. Perfect. Okay, part A is correct. Okay, so part A we've nailed. Next part is going to be part B. All right. It says show that 4x squared plus 36x minus 63 equals 0. Well, now we know the area is that amount. We already have shown that the area is 63. We did that originally. Lucky we did that. And then we can plug it all together. Therefore, 0 equals 4x squared plus 36x, take away 63, and tick, we've done that. And the last part there is to solve it. So let's go to the calculator. We're going to plug the 4 in, we're going to plug the 36 in, and we're going to plug the negative 63 in. Let's solve. We've got x equals 1.5 or negative 10.5. However, x must be greater than 0. Therefore, x equals 1.5. What is it asked? It's asked for the width of the pavement, which happens to be x. So therefore, 1.5 meters. Alrighty, guys, that's it. Hope that made a bit of sense to you. Any other problems, please feel free to email me some questions, and I'm happy to do a lesson for you on them. Otherwise, have an awesome day, guys. That's some quadratic practical equations.